so looking at these sum formulas, if we made u and v equal, we could rewrite this as the sine of 2u. It'd be u plus u. Okay?
Yeah.
So I want to come up here and show us what you did with the sine.
2 sine v cosine v u cosine u cosine u
Okay. 2 sine what?
sine u.
Okay. So you plug in a u here and a u here, and you recognize those are the same, right?
Yeah.
So you got 2 sine u cosine u.
Is there anything more? I was thinking about like.
Okay? Can we do anything more?
No.
No. Alright?
Yeah.
But that's it. Okay? That's it. Alright? So sine of 2u would equal 2 times the sine of u times the cosine of u. Alright? Let's think about tangent next. Alright? So I want to share with us, what did you do with the tangent?
2 tangent u over 1 minus tangent squared u.
Okay, good. If we plug in a u here and here, then the tangent of 2u would equal 2 times the tangent of u over 1 minus the tangent squared of u. Okay? That's not too bad. Not too bad. Then we have cosine. Alright? So cosine, we plug in a u and we get cosine of 2u. And what did you get when you did this one?
There are 3.
1 minus
The cosine is cosine u squared minus sine u squared.
Okay, so let's do that first. We plug in the u, and immediately we see it's cosine squared minus the sine squared, right? Okay, now, Howard, were you going to say something else?
1 minus 2 sine u.
Hang on, Andrew. Okay,
That's it.
that's it?
No, there's
No.
more stuff.
Okay,
Like,
so what did you do?
1 minus
1
sine
minus 2
squared.
sine squared.
Okay, so you did, right here for cosine, you did 1 minus sine squared, right, Howard?
What?
You did 1 minus sine squared, right?
No?
Well then,
Yes.
where are you getting a 2 sine squared from?
Is a cosine squared minus sine squared. Yeah, then just 1 minus 2 sine squared.
Okay, so yeah, so you 1 minus 2 sine squared. Alright, because what did you do with the cosine? You made the cosine squared into a 1 minus sine squared. So that's where the other sine squared came from, right? Alright, that's what I thought.
Wait, what?
Okay? He used the Pythagorean identity here. Cosine squared is 1 minus sine squared. So 1 minus sine squared minus another sine squared is 1 minus 2 sine squared.
Yes.
Okay? Now there's another thing that we could have done.
For
Made it
sine
into cosine.
u squared is equal to 1 minus cosine u squared.
Okay, so we have this cosine squared minus, and then if we use the Pythagorean identity but we substitute for the sine squared instead, we can do that, right? So how does that simplify?
2 cosine u squared minus 1.
There we go. Distribute the negative, so that's a plus cosine squared. Okay? So, we actually just derived all of our double angle formulas. And this is all of section 5. Okay? This is all of section 5 here. The double angle formulas. If we have two angles that are the same, in other words, or we just have a double angle, 2 times u, if we're taking the sine, it's 2 times the sine times the cosine. If we have the cosine of 2u, it's any one of these 3. And this is important to remember because there are going to be different occasions where using different ones is helpful. Okay? We'll see that later. And then with tangent, tangent is 2 tangent of u over 1 minus tangent squared. Okay, and here you have them all straight from the book. All right. Okay, I forgot to change that. This isn't SL1 anymore. There we go. All right, so there are our double angle formulas. Any questions on how we got these or what these mean? Okay, pretty straightforward, right? I mean, it's just another set of formulas. And the nice thing is, even if you don't remember what one of these is, if you know your sum formulas, they were pretty easy to derive, right? So we can figure these out with not too bad. Now, there's a couple of things that we can do with these. All right, obviously, it is possible to use these in proofs. Okay, that we've done a lot of proofs already. I'm not going to do an example of this necessarily, but I do want to do 2 examples here of a couple of different things that we can do with our double angle formulas. One is, how do we solve an equation where there is a trig function that just has x in it, but then you have another trig function that has 2x in it, okay? Every other equation we've solved so far, all the trig functions were trig functions of the same angle, okay? This is where these formulas, this double angle formula, there are also half angle formulas, the sum and difference formulas. This is where these come in handy because we're able to rewrite things a little bit, okay? One of the keys here, if you remember, way back when we started solving trig equations, the first thing was try to get everything in terms of the same trig function, okay? And kind of along with that would be also get your trig functions in terms of the same angle. All right, so here, one's in terms of x and one's in terms of 2x. So we can convert this sine of 2x. What would we convert it into?
2 sine x cosine x.
There you go. 2 times the sine of x cosine of x. Okay? Using our double angle formula for sine. Okay? Now, even though we still have more than one trig function in the equation, we know how to handle these ones.
Yeah.
Right? What are we going to do next?
2 cosine x times 2 sine x plus 1.
Okay, there's a common factor of 2 times cosine x, right? So we can factor that out. There's a 1 and then plus the sine of x. All right, and this is where now that it's factored, we know that either the cosine of x equals 0 or the sine of x would have to equal what? Negative 1, okay? Yeah, Liam?
I don't understand how we got 2 sine x the first step.
This right here? That comes straight from this formula.
Oh, okay.
We had sine of 2x, so we can change it, okay? Now we have a GCF of 2 cosine, so we pull that out, and then we can separate the factors, all right? So where does cosine equal 0? Pi over 2 and, good, 3 pi over 2. And where does sine equal negative 1? At pi, wait, no, not at pi.
Yeah,
3
fine.
pi over 2.
3 pi over 2.
At 3 pi over 2. Almost got me. 3 pi over 2. Alright? So we got a repeat here, which is fine. So here's our answer. Pi over 2 and 3 pi over 2 are our 2 answers. Okay? So, pretty cool now. Now we are able to solve equations where before, the only way we could have done this would be to graph it and see where it equals 0. with the calculator. Yeah, Andrew?
I have a question. Like the question doesn't give you the domain.
Mm-hmm.
So why don't you write like 3 pi over 2 plus okay.
We could do this and write it as, plus 2 pi n for a general solution if you wanted. That's fine.
On the test.
If it's not specified, go 0 to 2 pi. Okay.
So on the test, will you do it 2 pi?
Unless I tell you otherwise, yeah. So, if I want you to do some other range, like only give me the angles from 0 to pi, or give me the angles from negative pi to positive pi.
And in that example, like, we'd always choose one of those answers that would fit.
Yeah, if it was just 0 to 1 pi, then just the pi over 2 would be your answer. Okay? And if you think about it, that's kind of real life. A lot of times, especially if you were dealing with like a triangle, the biggest your angle can be, your angle has to be less than pi. That's 180. So even the biggest angle, the best you can do is 179.99999 degrees. Okay? So a lot of real life applications do have that kind of limitation on it where you're only going to get that smaller angle or something. Okay? Alright, so that's one example of an equation that we can solve that involves multiple angles. Okay? Let's try another one just for kicks. Alright, let's say we've got one like this. Let's say it's 3 sine of x plus cosine of 2x equals 0. Okay? Now I want you to think here.
We want to use the one that's sine.
Alright, yeah. We've got 3 different options, right, for cosine of 2x. 3 different options. We could either make it sine squared, we could either make it cosine squared minus sine squared. We could make it 2 cosine squared minus 1. Or we could make it 1 minus 2 sine squared. Alright? Now, Matthew's saying we should use the 1 minus 2 sine squared. Why would we use that as opposed to the other 2 options?
Because we want to get it in terms of one.
Yeah, this already has a sign over here, and we're not going to change that. The only way we could change it is to make the cofunction identity or something, and we're not going to mess with that. So, by converting this to 1 minus 2 sine squared x, we now have a situation where we only have one trig function.
Can we subtract one and then factor out a sine x?
Well, this is a polynomial one, right? We could do that, but how do we solve polynomials? Keep it equal to 0 and try to factor, right?
Yeah.
So, I'm going to rearrange this so it's a negative 2 sine squared x plus 3 sine x plus 1. And then what would I do next to make it easier to factor?
Flip the
Divide
signs.
by negative 1.
Yeah, divide by negative 1. Let's flip those signs, okay? So I'm going to make that a positive, that a negative, and that a negative, okay? And obviously, 0 times a negative stays 0. Okay?
Parentheses.
So now we can factor. I know it's going to be minus 1 and minus 1. And the only way to factor this is going to be 2 sine x and 1 sine x. Alright, let's just double check to make sure this does give us the right thing.
The last number, like 1, is minus in front of the 1.
Yeah, it's a
So
minus.
yeah, you can't write like a minus.
Oh,
1
wait,
minus 1.
sorry, yeah.
No, but yeah, it's still like wrong.
I don't think.
Well, yeah, that's what. Always double check. This would be basically the only way to factor it other than swapping the positive and negative. if I do this, I'm going to get a +2 minus 1, which is not a -3 in the middle.
Yep.
If I switch these,
Just gonna get
okay,
it's 3.
I'm going to get -2 plus 1, which is a -1, not -3. So this doesn't factor, does it? So what do we have to do?
Quadratic formula.
Yeah, quadratic formula, alright? So, A is 2, B is -3, C is -1, and here, once we figure out the quadratic formula, what is that going to tell us the value of?
This sine squared x, or sine x.
The sine of x. So the sine of x is -3, so +3, plus or minus the square root of 3 squared is 9, minus 4 times 2 times -1. So it's minus a negative, so plus 8 all over 2a, so that's 4. Okay?
Okay.
So now we have 3 plus or minus the square root of 17, which is what, like 4.1? Is that 4.1? 4.2 maybe?
4.1.
4.1? Okay, so now check this out. We get sine equal to either 7.1 over 4 or a -1.1 over 4. And what should I be thinking right now?
Sine can't be bigger than 1.
Exactly, sine can't be bigger than 1, so I know this one I can eliminate. And now I just have a case where I'm going to need to use my calculator to use the inverse sine, but I know sine of x is a -1.1 over 4. Okay, so I know my quadrants are going to be 3 and 4. What do you get when you plug into the calculator? The inverse sine of -1.1 over 4.
Negative 15.9.
-15.9.
Actually, it's negative 15.96, so it's like 16.
16.0, yeah, okay.
And then do we want to convert that, like adding 360?
Alright, so yeah, if I want answers, since we're in degrees, if I want answers from 0 to 360 degrees, I should add 360, and this is in which quadrant, by the way?
The fourth.
That's the fourth quadrant. So this gives me
344.
x is 344. Whoop, that's a big degree symbol. There we go. 344 degrees. Or, we said we'd be in the third quadrant, so what would that be?
Wait, isn't it fourth quadrant?
That's fourth quadrant. I also want third quadrant, because sine is negative in the third quadrant.
196.
Good, 196 degrees. Where 16 degrees is our reference angle, and we're going past 180. Okay? So 196 degrees. Alright? So that's one thing when you have that cosine of 2 theta. Make sure you think about what the rest of your equation has and how could I, or which of the 3 should I choose in order to be able to solve the rest of the equation. Okay? Yeah, Marcos?
How did you get 196?
Sine is negative, remember, in the third and fourth quadrants. This right here, -16, is telling us our reference angle is 16 degrees, right? So that's how we got the 344, 360 minus 16. But over here, if I have a reference angle of 16 degrees, and this is 180 degrees, you just add them, we're 16 degrees past 180, so that's 196. Sketch it out if it helps, okay? Sketch it out if it helps. It doesn't have to be pretty, just as long as it makes sense.
So in the unit circle, there's always, other than like on like the 0, 90, and stuff like that, there's always 2 values for sine or cosine or tangent.
Yeah. All right. Now, one last thing I want to look at, and that is, remember how we gave you the value of one trig function and something else that would indicate what quadrant we're in, and then you were able to find the other 6 trig functions. Okay? Well, or the other 5, I should say. You got all 6 in the end. We can also use that similar kind of information to help us figure out what sine, cosine, and tangent of 2 theta would be. Okay? So for example here, if I'm told that the cosine of theta is 5/13, and that my angle is between 3 pi over 2 and 2 pi, by the way, what is this telling us right here? Yeah, this is just telling us, hey, we're in the 4th quadrant here. I can figure out the rest of these. Okay? Now, thinking about our formula, sine of 2 theta is 2 times the sine of theta times the cosine theta. We only know the cosine of theta right now. How would we get the sine of theta?
You will use the
Pythagorean
formula.
Pythagorean identity, yeah, okay. The sine squared is, plus the cosine squared, which would be 25 over 169, has to equal 1. If I subtract, I get 144 over 169 for sine squared. So what does sine equal?
Square root of that, so it'd be 12 over 13.
Yeah, plus or minus 12/13. Okay? And by the way, if I am in the 4th quadrant, which one am I going to use? The minus one. Okay? So now look at what I can do. I have 2 times negative 12/13 times 5/13.
Some crazy stuff going on.
Okay? So I know it's going to be negative 120 over 169. And that is fully reduced, so you can just leave it like that. Does it make sense? How about cosine of 2 theta? What do you want to use?
2 cosine square minus 1.
Okay, let's do that. 2 cosine squared theta minus 1. Cosine squared, we already said, was 25 over 169. We saw that over here. So 2 times that would be 50 over 169 minus 1. So that's going to be a negative 119 over 169. Okay. Which means when I double this angle, I must end up in the 2nd or 3rd quadrant because cosine ended up negative, right?
Yeah.
So, okay. And in fact, which quadrant do I end up with when I double theta? Looking at what we see here.
3rd?
2 thetas in the 3rd quadrant. Why?
Because they're both negative.
Yeah, sine and cosine both ended up negative, right? So, so good. That's thing. By the way, also look at sine and cosine. See how close they are together? That means 2 theta is really close to what angle? Yeah, 225. Think about it. 3rd quadrant. Where is sine and cosine equal? It's at 225. So my angle must be, or at least my double angle must be pretty close to 225. Okay? So, Well, at least a coterminal of 225, because if I double a fourth quadrant angle, I'm going to be more than a full circle. But yeah, we're going to be near that 225 mark. Okay. Now, tangent of 2 theta. We have a couple of options here. What do you think the easiest option would be?
Sine into
Sine over cosine.
minus divide cosine cosine.
Yeah, we already did the hard part here using our formulas, right? Tangent is sine over cosine. So tangent of 2 theta is sine of 2 theta over cosine of 2 theta. All right? So sine of 2 theta is 120 over 169. If I'm dividing by cosine, I'm going to flip and multiply cosine. All right, so this is 169 over a negative 119. So I get a positive 120 over 119. It's just over 1, which tangent of 225 is 1, so that makes sense. Okay? So these are the couple of different things that you could do with these double angle formulas. All right. So pretty cool stuff that we're able to do here. Okay. All right. Now, if you looked at the Sunday post leading up to today, I did make some slight modifications in the what problems I'm having you do for tonight. It's actually fewer, okay, than I originally had on there. All right. I'm only having you do up through 15 right here. Okay, let me do this. Okay, so I'm going to have you do this through 15. Okay? So I'm going to give you some time to try some of these. They give you some triangles to start with what we just did. Then you've got a couple of equations, all right? You can solve these without using the calculator, but you could use the calculator to double check your answers. And then here, again, you're finding the exact values within a certain interval, okay? So we'll go ahead and give you the last 10 minutes to start with that.